And there's a lot of hooey that's, you find on the web about this. So quantum entanglement has mysterious properties and non-mysterious properties, and unfortunately they get mixed together. The way you entangle two things is, suppose you have some object which has a property that is zero, and it decays into two things. And in the decay, that property can't change. So it decays into one thing, and say that guy's got that has a property of one. Well, then the other guy has to have a property of -1 because it started with zero. And if you have two things, you've got one, the other one has to have -1. They add to zero, and everything's cool with that. So that's kind of what happens is we create particles, and then we separate from one another. And they will always have, the entanglement part is they will always have the opposite. Whatever one has, the other one will have the opposite of it. That's what entanglement means. And that in itself isn't so incredibly interesting because, if I told you you had a red sock and a blue sock, and that's the only socks you had, and I put a red sock in a box, then the other box is blue. You just do. But it is more complicated than that. And then you have to get much more deeper into quantum mechanics, and probably more than you want to spend time talking about. But because the properties we're talking about are not color, they're not socks, they're not anything. They're things like the direction in which these particles act like they're spinning. And you start out with something with zero spin, and if one's spinning in one direction, the other has to spin in the opposite direction. That's just how it works. But because quantum mechanics, you can measure like the direction of which you're making the measurement, and it can be up and down or left and right. And you can like change your mind. In non-quantum mechanics, if in what I told you is true, if something was up, something is down, that's it, the end. But with quantum mechanics, you can later say, oh, I don't want to measure up and down. I want to measure left and right. And in measuring one of them left, the other one pops to be right, even though you knew ahead of time that they were up and down. And so that's where quantum mechanics gets really wonky. But the entanglement part simply says that two objects created together can have properties such that they are basically mirror images of each other, no matter how far you separate them. And precisely what's mirroring, well, it depends on the measurement you make.